A cap. If you wanted to bring this, you actually don't need to bring this ferromagnetic one. You have to bring a capacitive proximity sensor. So this one. So if I do this, that means the amplitude of the magnetic flux in between there is lower, and then the amplitude, once it is low, the trigger circuit happens to give me a signal. Let's put the program in the PLC. We download the program. We transfer it in the PLC. Take a little bit of some time, maybe like 5 seconds. It's downloaded in the PLC, and then we can choose to run the PLC. So now we have run the PLC. But now remember the condition I gave to the PLC in this kind of a program. We have said our input is X0, which is this. It is connected in the normally closed condition. And then whenever I activate this, the normally closed is, whenever I activate this one has to give me an output. Let's try it. I think you can see. So whenever I just do this, I bring any object closer to here and it detects something, immediately it will convey the information to the PLC, and the PLC is being commanded turn on Y0, and then the Y0 is going to take the information to the relay, and then the relay will command the light to be on. Yes, welcome everyone. As we talked in the previous videos, we are going to be sharing about the equipment that are used in automation or industrial automation, whatever you may call it. And in today's video, I'm bringing to you the proximity sensor. So this proximity sensor, we always have different types. We have capacitive and we have inductive proximity sensor. But depending on the application you want to use, you will choose rightly. You have to choose rightly. So think about, you have an application you want to detect some passing objects in front of this sensor on a conveyor belt. And maybe when you sense the object, you tell the PLC maybe you have to stop the motor or you have to continue the motor. So in that kind of a thing, you have to first see which object are you detecting. Are you detecting a metallic object? Are you detecting a ferromagnetic object? Or are you detecting maybe a non-metallic or non-conductive element, let's say a box or a rubber thing or a bottle? So depending on that, you have to choose rightly. So in this case, I'm dealing with an inductive sensor. So if I'm dealing with an inductive sensor, it is strictly to detect ferromagnetic objects or maybe metallic objects, as long as it conducts. So in this, it has 3 terminals. These 3 terminals, there is a positive and negative, and then the output. So the positive and negative are to give it the power supply, and then the output is to give us the signal. Because inside here there are 4 circuits. There is the oscillator circuit that is helping us to produce the electromagnetic field, which is going to be interacting with the with the target. Let's say this part, which is ferromagnetic. So this is our target, and then here we are producing the electromagnetic field. So it is being produced by the LC circuit inside the oscillator, and then we have the trigger circuit, and then we have the output. The output is going to come from here. So it also has the indicator. So I can show it to you over here that it is not lighting. And then if I bring a ferromagnetic material near, it is going to show to light, you see? And then the best advantage of this feature, this kind of a sensor, it has no moving parts, and then you expect it to be living for a longer life. It has a longer lifespan since it has no movable parts. But you can see, if I'm detecting something that is not conductive, if I put close, even if they get into contact, there is nothing that is happening. But if I bring a ferromagnetic material closer, it is going to be detecting something. So if it detects something, my PLC, my output is directly given to the PLC, and based on the program that I have put in my computer, I'll be getting an output. So a minute. I'm going to put in a program The program that I need to put in this PLC is whenever this one detects any kind of an object, it should be lighting this lamp. So let's say maybe there is a conveyor belt, and this conveyor belt is bringing boxes or any metallic thing and passes here. And remember, every sensor has a range of sensitivity. So this itself, it is having a range of 0.8 centimeters. That's around 8 millimeters. It's a very small sensitivity area. Something like this is actually not up to, its sense limit is something around this, very, very small. So with this kind of a thing, we want to put in a program whenever we detect anything that is passing through here, anything that passes through here, and then you can see the closer I go, the more it detects. If I go a little bit further, the sensitivity is not around that sensitivity, so it has to be closer. And guess what? When you bring it in the sides, there is no magnetic field, because actually how it is built is like there is a ring cap over here that is directing the magnetic field in just one direction, not to the, it has to be tangential. So right about now, let me load the PLC, let me load the program in the PLC. It's just a simple program, an input, using this as an input, and then we get the output to Y1, and then this Y1 is connected to the relay. This is the other circuit that I showed in the previous video. So it's connected to the relay, and then the relay will have to switch on this. So with that in the PLC, and then we can choose to run the PLC. So now we have run the PLC. But now remember the condition I gave to the PLC in this kind of a program. We have said our input is X0, which is this. It is connected in the normally closed condition. And then whenever I activate this, the normally closed is, whenever I activate this one has to give me an output. Let's try it. I think you can see. So whenever I just do this, I bring any object closer to here and it detects something, immediately it will convey the information to the PLC, and the PLC is being commanded turn on Y0, and then the Y0 is going to take the information to the relay, and then the relay will command the light to be on. As I said, this inductive proximity sensor, it is only going to be working with objects that are ferromagnetic. So if I bring any object, maybe let's say I bring this calculator, I expect it not to be ferromagnetic. So when I bring it closer, there is nothing that is happening. Nothing that will happen. So if I bring anything, maybe this can, I expect it to be ferromagnetic. It's going to react to it. It's reacting to it. So what does it mean? That if you're going to go out there looking for any application, maybe you're going to design a system for a client, you have to first know what product is he dealing with. And after knowing the product that he's dealing with, you're not going to just order a sensor. Whenever you're going to order an instrument, you have to first look for the instrument that really matches your application. So if you wanted to test something like the presence of a water bottle, let's say this, or maybe a cup, if you wanted to bring this, you actually don't need to bring this ferromagnetic one. You have to bring a capacitive proximity sensor. So this one would react to it. If this was, they all look identically the same, but internally what is the principle of operation is different, because in the capacitor we are using the capacitor, so there is one plate inside here, and then this is the other plate. When you bring them together, they will create that magic field, and then it happens. But in here, the principle that is there, the principle that is working is when I bring this ferromagnetic material, already there is a electromagnetic flux that is flowing in this field, and when I bring this other ferromagnetic material, there is eddy current that is going to be generated in this field, and then it also produces its magnetic flux, which is going to be repulsive, like in an opposite direction of the primary, so it cancels it out. And when it reduces, the trigger circuit will check the amplitude of the total flux that is being generated over here, and once it is lower, that's when you get the output signal, like, you know. So if I do this, that means the amplitude of the magnetic flux in between there is lower, and then the amplitude, once it is low, the trigger circuit happens to give me a signal outside. So advantages is you don't need contact. That's one of the advantage, which is leading to a long life. So based on the application, you look for maybe a larger sensitivity area. So if you don't want objects to be much more close, you know, something like that. Hope you understand this kind of a system. We shall meet in the next video. Thank you.